A very good morning to all of you. I hope everybody is fine and staying home, staying safe. We have completed three bottom layers of OSI. We did physical layer, we did the data link layer as well as the network layer. Today we'll be starting the fourth layer from bottom up approach, which is the transport layer. And transport layer being one of the important layers in OSI would have to go in details the functions that transport layer would provide. It basically does the logical communication between the two sides, and we'll also see what devices come across in the transport layer. Am I clear? All right. So let's begin with what transport layer is. I have given you a sheet uh, in which we have examples and the details of OSI layer. The first thing that we have here is that it's layer number 4, and the protocol data units that we call within this layer are segments. Like in network layer, I call these PDUs as packets. Data link layer, frames, physical layer, bits. Now if I say a segment is being transmitted from one end to another end, consider that I'm talking about the transport layer. The keywords or the main description of the transport layer is end-to-end connection, reliability, that's very important, segmentation, desegmentation of data in proper sequence, and flow control. Another thing is that in the table you would see that devices or component, it's empty. It's basically PC there. So end-to-end devices, that is your PC and my PC. If I'm chatting with you, transport layer is available on my PC and on the other PC, that is your PC. It is not available in the intermediary nodes like router, hub, switch, repeater, and so on. It is not available there. It's only available from end-to-end systems. Transport layer is named in OSI as well as transport layer, as well as in TCP IP. It's also named as transport layer. It has two main protocols, which is TCP and UDP. TCP is so important that the TCP IP layering is named by this protocol itself. There is SCTP also, one of the protocols, SPX of IPX or DDP, and so on. So let's begin with what transport does. The first thing that it does is a logical communication. This is the overview of what we are going to study when it multiplexing, demultiplexing, reliable data transfer, flow control, congestion control. We'll be learning about TCP as connectionless service. We'll be learning about UDP as UDP as connectionless service, TCP as connection oriented service, and also we'll be learning about the TCP congestion control. So the first point is that transport layer provides for logical communication between application processes running on different hosts. So application processes use logical communication provided by the transport layer to send messages to each other without actually worrying about the physical layer or physical infrastructure that is below it. So there's an abstraction of all whatever is below, and it will simply start sending the data. And when we say logical communication, see in the picture here, logical end-to-end transport. Like I had shown you at the data link layer also, logically, how do we see it? Likewise here, we say there is a mobile here. Let me annotate it. There is a mobile here and there is a server here. Let's say you are accessing Google. The transport layer would be available within this mobile as well as it would be available within the server here. And we say that of transport layer of the mobile would start communicating with the transport layer of the server. This is what we call as logical end-to-end transport. Now, why is this logical? Because logically, they are communicating with each other, the two transport layers. But we know actually, physically, this doesn't happen. Why? Physically, this is the actual path that it will have. Let's say you are using messenger, so messenger would give the data to application layer, application to transport, then network, then data link layer, then physical layer, then it would go to wirelessly through this, then to wired through this router, then as per the shortest path available, it would reach the first hop router of it, and from here it will connect to the server that we have here. At this server, the physical layer would receive it, take it up to data link layer, network, transport application, and give it to the application, that is the Facebook Messenger in this case. So the red line here, which I have made, denotes the actual path, whereas the two arrowed line here denotes the logical end-to-end transport. Another part that we have to understand here is logical end-to-end transport. Why is it end-to-end transport? For this, I would draw a figure here to understand what we mean by end-to-end. We say in the transport layer, we have only the protocols that are end-to-end protocols. How do we define them as end-to-end protocols? For it, I will draw a figure here. For this, I would draw a figure here. This is, let's say, my system. On the other end, there is a server. There are intermediate devices like switches here. There are intermediate devices like hub, switches, as well as routers. Okay. Now, let me just join them. So what you would see here is that when the data is sent from the higher layers and it goes into this, that is the transport layer, I'll write it as TL. Transport layer passes to the lower layers, okay, then it goes through to the physical link and then it goes to the first device. The first device here is a hub. Hub is a physical layer device, okay? So it would go to only one layer, that is the physical layer. It would not understand any protocol that belongs to the data link layer, the network layer, the transport layer, the session application, or any layer above it. Moving on to a switch, which is a layer 2 device. It would receive it, it would understand that these are bits at the physical layer and then frames at the second layer, that is data link layer. So it can understand the protocols belonging to bottom two layers 1 and 2. Move on now. The packet moves to the router. Router is a layer 3 device. So it starts from the physical layer, data link layer, network layer. So it goes up to the three layers, bottom three layers. And router would not understand what are the protocols of transport layer. Then it sends to the server. Server takes it from physical to the data link layer to network to transport to session presentation and gives back to the application. In other words, I want to say here that transport layer here and transport layer here. No other device in between has a part of transport layer. And that's why we say the protocols of transport layers are end-to-end protocols. They are available from one end to another end, not in between the two. No other devices in between the two comes. I hope this is clear. So this is about logical communication of two transport layer segments. And also there is a end-to-end communication in which no other intermediate device would understand what is being communicated. They would simply consider this as packets and they would pass it on. Another thing is that network routers would not act on transport layer, which is clear from this figure. The transport layer would get data from its higher layer, that is either application layer or session presentation layer, depending upon whether session or presentation layer is being used or not. We'll see them in coming classes why we would use them or why we won't use them, because both the layers being the optional layers. And in TCP IP, they have been combined together and formed a single layer with application, session, as well as presentation layer protocols combined together. So the higher layer protocols would use the protocol stack. They would use the service model in which you take the help of the lower layers to pass on to the data. In this case, you'll give the data to transport layer. So you can get messages as chunks, okay? Bigger chunks, and transport layer can convert these messages into smaller chunks, add a transport layer header, and then pass on to the network layer. Thus, we say transport layer provides logical communication between processes running on different systems. I'll mention this point here. I'll just write it here. So transport layer provides logical communication. Between who? That's important to note. Logical communication between processes running on different systems. Now let's compare it with the network layer. In this case, we say network layer provides, or network layer protocols provides logical communication between hosts. So in other words, transport layer connects the applications and network layer connects the hosts. Another thing that we need to keep in mind here is that services that the transport layer protocols can provide are often constrained by the service model of underlying network layer protocol. We have understood service model in our previous classes as well. So in this case, what does it mean? It means that some services in which, let's say, a network layer cannot provide a certain guarantee, like network layer says, I cannot provide guarantee with respect to bandwidth. I cannot provide guarantee with respect to delays and jitter and so on. So when the lower layer cannot provide a certain guarantee to the higher layer, then transport layer also cannot provide guarantees. It will also say, sorry, I cannot provide you bandwidth guarantee. I cannot provide you delay guarantee. Why? Because the underlying layer, that is the network layer, is not able to provide me these services. But keeping this in mind that yes, there are constraints there. Transport layer can offer some services which the underlying network layer does not provide. And the example of that is that transport layer can provide reliable service even though the underlying network layer is unreliable. Even though network layer says that I cannot guarantee any of the services, but transport layer can provide those guarantees. I repeat, some things network layer can provide, then only transport layer says I can give you guarantee if my network layer gives you guarantee. Some things which network layer does not provide, but still transport layer can provide. In this case, that is reliability or reliable service. As an example from the book, so this is the statement just now mentioned, that network layer provides logical communication between hosts, whereas the transport layer provides logical communication between processes. So it relies on transport layer relies on network layer, but not just relies on it, it can enhance some services as well. So I have a sender here and the receiver. Sender pass the message from the application to the transport layer. And what does transport layer do? It does the functions that it is supposed to do, whether it's about reliability, whether it's multiplexing, demultiplexing, whether it's creation of a segmentation, and so on. It does that. And the information that it does is kept in the header. And that header, we call it as the transport layer header that's added to it. And then the combined data given by the application and the transport layer header, it forms a segment, the addition of these two. Segment is, this is how segment is created, is then passed to network layer. Network layer adds its own functionality, so and passes on to the data link. Physical layer would send it as bits across the link as ones and zeros, and the receiver would receive these ones and zeros at the other end, and the pass on to the physical layer here. Physical layer would send it up to the transport layer. Transport layer would identify the transport layer header, open it up, like in the example it was given that they are put as an envelope. Open the envelope, see the contents of the header within it, how to demultiplex, how to do desegmentation, and so on, and pass on the remaining payload or the data to the application that is here. Then the application layer would pass on to the application. There are two principal internet transport protocols. There are two services that the TCP provides, TCP IP network would provide. One is known as TCP, which stands for Transmission Control Protocol, which is a reliable in-order delivery with congestion control, flow control, and has a connection setup. The second one is known as UDP, that is User Datagram Protocol, which is unreliable, unordered delivery. All right. It's like an extension of the network layer's best effort service. We'll take each one of them one by one. We'll understand why would we require this, why we need TCP, why we need UDP. Sometimes, generally, the layer N, layer 4 PDU is referred to as segment, like I just now said. But some books might refer TCP PDU as a segment and the UDP PDU as datagram. Why? Because UDP has user datagram protocol within it. The word datagram is there. So they might say datagram for UDP and segment for TCP. And the fundamental functions that the UDP as well as TCP would provide is that it would extend the internet protocol IP's delivery services. How? It would extend the network layers host to host delivery to transport layers process to process delivery. So this extending of host to host delivery to process delivery is called transport layer multiplexing and demultiplexing. On one end, we say that it would extend IP's delivery service, but some services which are not available in transport layer as well are, there are no guarantees of delay, there are no guarantees of bandwidth. So I came to this multiplexing and demultiplexing. There is some error checking as well done by TCP UDP, integrity checking, like we have error detection fields in their header. They help in error checking as well as TCP provides certain type of congestion control, which we would be discussing. Let's start with the transport layer functions. Before I go to multiplexing and demultiplexing, the first function that I would want to take here, functions. The first function that I want to take here is process level addressing. Process level addressing. Now coming back to addressing. Addressing at layer 2, that is the data link layer, deals with hardware, the MAC address, the physical address, and so on. It identifies the NIC that we have, the network interface card. The addressing at the network layer would deal with the IP, that is the IP address. And here we have addressing also performed at the transport layer, where it is used to differentiate between the software programs. So this is what we call as process level addressing. This is what actually enables many different software programs to use a network layer protocol simultaneously. Or in other words, if you are using, let's say, a browser, Chrome, to access a web page, and on other end you are using, let's say, Facebook Messenger. It ensures that hi, hello from the Facebook Messenger does not go into your Chrome, and the HTTP GET requests and so on from the Chrome does not go into the Facebook Messenger. So it differentiates software programs so that you can use the network layer or below protocol stack or OSI layer, all of them separately for two different software applications. And the example of transport layer process addressing is the port mechanism. So we have TCP and UDP port. Do you get the idea now why we have so many addresses? Why we have address at physical layer? We have address at network layer. In fact, we did the comparison, like if we have address at physical layer, what we need network layer. If we have network layer, what we need at physical layer. Now I'm talking about the third thing. It's like port mechanisms. That is, addressing mechanism at transport layer. And what would we require it? Obviously, there are lots of programs running at the same time. There is your antivirus that is getting updated. There is your operating system that is getting updated. There is a browser. There is, let's say, a music player. There is a chat. There is a game online which is going on. And all of them are sending and receiving packets simultaneously. They are connected. They get the data and they send the data. Now, how to ensure that this data is separately sent to each of the application? One's application's data does not go to the another one. This is where the process level addressing helps. And these addresses are UDP and TCP ports. This would allow applications individually reference to any TCP IP device. This is the first function. The second function that we have is multiplexing and demultiplexing. For that we have, okay, an image here. So what is multiplexing and demultiplexing here? In general, let me first do one thing before I start writing all of these. Let me just write some of it. Let me just first write the functions as a list. Multiplexing and demultiplexing. Then number 3 we have, and what is multiplexing, demultiplexing? The sending device multiplexes the data received from the applications. Now you have to again understand, many applications can send the data, and this is combined within a single segment. Okay, it can be different programs sending the data, and these programs are sent within the same transport level segment. This is where we do multiplexing, and the demultiplexing would be done at the receiver end. How it is done, we'll be taking that as well. Okay. The third function is segmentation, packaging, and reassembly. What is this? If you get a large amount of data from the application, the transport layer would break it into segments and send over the network into smaller pieces from the source machine. Then only it would pass on to the other end. Now we did this in earlier classes. Why don't we send a whole message? Why do we break the message into a number of smaller messages or segments or packets? We understood that earlier as well. It looks conceptually if you see segmentation, it's like breaking up of a bigger data into smaller data. How does it seem to be? I mean, the name resembles to something that we studied already. Can anybody tell me what was it? Yes, anybody? Okay, I repeat the question. Segmentation resembles to a term which we already studied. What is segmentation? It's breaking up of large amount of data in smaller pieces and then sent over the network. What does it resemble to what we studied some classes back? Anyone? Good. Akif says fragmentation. Exactly. It resembles to fragmentation that we studied in the network layer, in which if we get a bigger chunk, we break it into smaller chunks. Correct. So likewise, fragmentation here is known as segmentation. Why would we do segmentation? Why would we do fragmentation? We'll come to that as well. Just like the network layer fragments messages to fit the limits of the data link layer, the transport layer segments messages to suit the requirements of the underlying network layer. This is all below the network layer. That would be the data link layer as well, right? As well, in that sense, you are breaking up the data. Now, all this framing, fragmentation, segmentation, we all do these so that we want to fit our protocol data unit within the limits of the lower layer. And this has to do with MTU, that is the maximum transferable unit that we can send across. Right? Good. Okay. So we'll take this, how segmentation, packaging and reassembly. Obviously, break it, put it in an envelope and send it. That's packaging. Reassembly is once you get it, you need to assemble them. It would depend upon ordered, unordered services. Its functionality would depend on that as well. And then the fourth function that we'll study about is connection establishment, management, and termination. So transport layer has a service which is connection oriented service. We would have protocols and connection oriented protocols which are responsible for establishment of a connection. Okay, which we have studied something in like virtual circuits, right? We had establishment, we had a call setup, but that was different and this is a bit different. We'll understand how this is different. Why? Because this is in order to ensure that we have a reliable data transfer. Number 5, fifth function. We have acknowledgements and retransmission. Part of the connection oriented service, part of the reliable service, in which we have transport layer protocols which guarantee reliable delivery of data. The common technique used here is acknowledgement and retransmission times. So if you send the data, if it's received, an acknowledgement is sent back. If it doesn't, then you would need to have a retransmission. This, we are going to study how this is done as well. And the last function that we will have error recovery also. Number 6 is flow control. We'll see transport layers flow control as well. And number 7 is error recovery. Also, in connection setup, we would require not just establishment, we would need to manage these end-to-end operations. Okay. This is basically the functions that the transport layer provides. But in addition to these duties, transport layer also supports certain activities. So I will write here supports. What does it support? Maintaining integrity through flow control. So setting up and taking down of virtual circuits, VCs, virtual circuits, it supports that as well. Hiding any network dependent information. So we have abstraction also that is done by the uh, transport layer. What abstraction? It's hiding any network dependent information from the upper layers, which only would actually confuse them. Breaking down of the data passed from the session layer, yeah, we did that in segmentation. We took that in the monitoring of error-free delivery, error recovery. I took that as point 7 as well. Yeah. And the examples that we have, I'll write here as well. Examples: TCP, UDP, SPX. TCP and UDP will be taking up in detail. SPX is the novels protocols, which is like TCP. What is novel network? We took this example some time back, proprietary protocol stack. SPX stands for Sequence Package Exchange. So TCP on one end of OSI, open source interconnections, and the novels proprietary is SPX. NW link, network link. This is the shortware for network link. This is the Microsoft's version of novels, IPX and SPX. ATP, NBP as well. This is the Apple Talks data transport protocols, where ATP is Apple Talk transaction protocol and NBP is name binding protocol. And the last example that we'll put here is net bias or NetBui, BEUI, which stands for Network Basic Input Output Systems, or Net Bias Extended User Interface, EUI. Net Bias Extended User Interface. Again, Microsoft's network protocols that work together to manage communications and provide data transport services. There are some services which would be connection oriented, some services which would be connectionless. The examples of connection oriented service include frame relay, TCP, SPX, X.25. The example of connectionless protocols is UDP, IX. IPX is actually, network layer protocol as well. Is this part clear? Any questions till now? No questions? Okay, I had told Ramadan today that I won't hold you for long. All right, I'll just functions of this. The multiplexing, demultiplexing, I'll start from the next class. We'll start the functions individually one by one from Monday's class. Right, I've given you assignment also, assignment number 3. Well, if you take lab separately, otherwise it's assignment number 4. So there are due dates also. I hope you'll submit those on time. Then probably once we are done with the transport layer, we would try to have an online quiz. We'll see the modalities, how we can go about having the quiz as well. Any questions? Ramanand? Should we end the class then? All right. All right, we'll come to you on Monday. All right, thank you. Everybody. Take care, guys. See you on Monday. Bye-bye. Any questions, queries, issues, please email me. All right, you have my email address. Just email me. I'll just still type in here. All right, bye-bye.